Okie dokie guys, let's have a look at the last question then on the C2 paper, the question 9. There's parts A and B. We've got this picture here which puts most of the information in. It says we've got a circle. The diagram shows 2 points P and Q. There's P and Q on the circle. Center is O. Radius is 4 centimeters. The tangent of the circle at P, here it is here, intersects the line OQ at the point R. Okay, the length of the arc PQ, so this arc length around here is 5.2, and POQ, the angle POQ is theta, which is put in the picture. The only thing that's not put in the picture is the 5.2. The first part then, find the value of theta. So let's go to the little sketch I've done here. The arc length I've put in here is 5.2, and it says find theta. Okay, well the arc length is 5.2. So what fraction is that of the whole circle? If we know the whole circle, we'll be able to find the fraction theta is of 2 pi, won't we? So circumference then? This is the easiest way I like to think of these problems. The circumference is pi times diameter. So that would be, the diameter, radius is 4, so that would be 8 pi. Now the fraction of the circle that the arc, the angle subtends theta, well, it's 5, the length is 5.2, right? The whole length is 8 pi. So the fraction of the circle that will tell us the radians, won't it? If I use this phrase, fraction of the circle, the fraction part will be this length, 5.2 of 8 pi. That's how much of the circle, proportionally speaking, as a fraction we've got. And then the whole circle is 2 pi, isn't it? In terms of its radians. So it's a fraction of the circle in radians. There we are. So that's what we should have. So it'll be 5.2 divided by 4. Let's get our calculator. 5.2 divided by 4 equals, and that's going to be 1.3. So we've got 1.3 radians. So radians. Okay then. And that's the answer there. I'll just run through it again. The way to do this problem, rather than remember any formula for arc length of a sector of a circle, is to basically remember the circumference is pi d, that's the whole length around here. Pi times diameter. The diameter is 8, so it's 8 pi, or 2 pi r, whichever way you like to think about it. So this whole length is 8 pi. This small segment length around here, and this curved arc length, is 5.2. So 5.2 parts of 8 pi will tell you the fraction this is of the whole circle. Here's the fraction. Here's the whole circle, and in radians it's 2 pi, isn't it? So that fraction of 2 pi will be the number of radians we've got. Yeah, that much of 2 pi. Agreed? The fraction of the circle. So you just remember that sentence and put the numbers in, and you get the answer for 9 part A. Good? Great, so let's go on to the next part, part B now. Great.